Okay, this is questions from, oh, I gotta take this out of here. There we go. Questions from 7.1 in your grade 9 textbook on multiplication and division of polynomials. Section 7.1 involves simply multiplying and dividing monomials by other monomials, and you are required to know how to do it through modeling and through methods without modeling. So we have 4 questions here. The first question gives you 4x multiplied by x, and it says solve it by modeling. So the model we use for all, sorry about that cough, the method we're going to use here is an area model. So if we think about a rectangle real quick, a rectangle has a length and a width. And way back when you learned that area is equal to length multiplied by width. So the area would be what's inside here. The same thing happens when we do an area model. So with this red thing that I've done here, this is really the length. And this is really the width, or vice versa. It doesn't matter which one's which. And the inside is really the area, or the product of the length multiplied by the width. Okay? So what we end up doing is just use this model here to show length and width. And we do not represent length and width with numbers, but rather algebraic tiles. So this is 1x, and 2x, and 3x, and 4x. That's the length. This is an x, an x, an x, and an x, which is 4x. The width we will represent with an x. And inside here, I guess I'll take a blue marker. Inside that blue dotted line is a rectangle's area, which would be the product of 4x and x. So if I draw my little lines here to separate each of those, since this is an x, this would be x multiplied by x, which means its area is an x squared tile. So that would be an x squared tile, which we're going to represent by shading it in. Show it's a positive x squared. Therefore, from a model perspective, a 4x multiplied by an x gives me an area of 4x squared. So 4x multiplied by x, according to our model, gives us the product of 4x squared. Our second question asks us to do it, but rather than model this particular question, oh, I don't want Zach Brown. I do like my Zach Brown band. What it asks you to do is rethink this question without modeling and use redistribution of terms. So a 4x squared is really a 4 times an x multiplied by a 2 times an x. So if I think about what this means in separate parts, since 4x squared is 4 times x times x. So if we think about that as being this whole string here, what I'm going to do is I'm going to rethink of it as being a 4 times a 2 times an x times an x times an x. Because of the associative property of mathematics, the order in which you multiply terms in a string of terms does not affect its product. So rather than multiply the 4 by the x, I'm going to go the 4 by the 2 first, which is going to give me an 8. And an x times an x times an x, since we studied exponents, is going to be x cubed. So therefore, 4x squared multiplied by 2x will be 8x cubed. Your third question asks you to solve the division of the monomial by the monomial using modeling. So this time, if we think about length multiplied by width equals area, and we use our basic algebra sense that if I was to divide both sides by, let's say, length, algebraically I'd be left with the width is equal to the area divided by the length. Now this is important because this idea is what our modeling here is all about. So this top number is going to represent our area. So 4x squared, and our bottom number is going to represent our length. And what we're going to solve for is the width. So let's see what that looks like from a modeling. Since this is our rectangle, this is going to be our area, and this is going to be our width or our length, it doesn't matter, and this is going to be our length. What we're really going to do here is we're going to put the things we know up into our model, and we're going to solve for the ones that are missing. So the first thing I'm going to put up actually is our length, and it doesn't matter where I put it. I'm going to put it here. So in negative 2x, we're going to allocate two algebra tiles that are x's, but they're both negative x's. So we have a negative x and a negative x. So that's going to be our length. Inside, we're going to do our area, which is 4x squared. So if I think about how I'm going to fit that in, oh, those are the world's worst x squareds. I got to make these a little different. Hang on. Too long. Let's go this far. That's better. That's still awful, but anyway, you get the idea. So when I draw that in here, I'm going to put positive x squared. So that's going to be a positive x squared, a positive x squared, a positive x squared, and a positive x squared. So our area inside that rectangle is 4x squared. So now we have the area here, the length here, and the width that's missing is going to be the side of our model that we don't have. So now we have to do some thinking. If this is a positive x squared and this is a negative x, what does this have to be here in order for it to multiply to give you an x squared positive? It has to be a negative x. And here has to be a negative x as well. Because a negative x times a negative x will be a positive x squared. Just because of our sign rules of integers, right? A negative multiplied by a negative is a positive. So I've solved the missing side. This has to be negative 2x, which means the solution to our question, what is 4x squared divided by negative 2x? The solution would be, it's negative 2x. Okay? Does everyone kind of get that? The area model's harder. The hardest thing of the 4 questions is that question right there. Now let's just, I know we didn't have to do it, but let's just look at this question. If I think about it using a non-modeled part. What would we do here if we solved it without modeling? What would I ask myself first? What is 4 divided by negative 2? And what's 4 divided by negative 2? Negative 2. What is x squared divided by x? It's x. So see how we got the same solution? Obviously, this is the easier method, correct? Right? That's a lot easier. But the department wants you to be able to represent this idea concretely, which means you have to be able to draw an area model to solve it. So it's important that you know it. Will you use it when you do polynomial division? Probably never. You will always use this method that we just talked about there. So you won't, by default, you're going to use this method. But it's still important that you have a representation of what it means. Okay? And your last question asks you to do the division of the two without modeling. So again, we're going to think of it, and I'm going to just write it out the way we thought about it before, as 15 over 5. Actually, I'm going to do it like this. 15 multiplied by x over 5 multiplied by x. So we see how 15x squared is really 15 multiplied by x, or 15x squared, over 5 times x, which is the same thing as 5x. So we're going to break it into parts. 15 divided by 5 is going to give us what? 3. Now what happens here? They cancel each other out, right? They kind of become a multiply by 1, which we talked about before, which doesn't affect it. And what's this left here? X. So x squared divided by x gives us just an x. And our solution for 15x squared divided by 5x, without modeling, is just 3x. Now, do I need you to do this every time? No. You don't have to write that out. But I do need you to understand why it works the way it does. Okay?